Hello, can you hear me?
Yes.
Okay. I'll ask you now to stop working on the project for some minutes because I'd like to, before we end today's session, I'd like to present the work that you should do during next week before Friday session. Remember that today it's Thursday and it's the first session because tomorrow is not a working day in Madrid. But from next week on, all sessions will be on Fridays from 10 to 2, from 10 to 14. Okay. And you're supposed to do some work before next the second session during next week. And I'd like to talk a bit about it. I'm recording this as before, and I'll share with you. I've already shared the video of the introduction for today's session here, and I'll do the same for all these presentations. I'll share them in the GitHub. I've already published the tasks to complete next week from May 18 to 21. The second session will be on Friday, May 22. And here is a summary of the tasks that you should complete. And more details are given inside module 2. So let me go inside that module because all those tasks are extended here, and there are more details. So let me look at them here. So first thing you're asked to do is to review concepts on input-output general concepts such as memory mapped input-output, program-based input-output, interrupt-based input-output, and all those things that you probably all studied during your degrees, but maybe you have forgotten some of them. So the idea is that you refresh all those concepts so that you can then do the exercises in this module. This is the second module. Also, given that the SOC that we're using is programmed in Verilog, you are also recommended to review those concepts about system Verilog. I don't know if you're familiar with this HDL language. Maybe yes, maybe you've used a different HDL language such as VHDL, or maybe you have used Chisel, which is a higher level language. Anyway, conceptually they are similar, and you shouldn't have many problems if you've used one to move to another. In this case, you will use Verilog for some of the exercises. Don't worry, it's not, you don't need to be experts in Verilog. It's easy things that you'll be asked to do. So please, if you need it, review Verilog programming or system Verilog programming before next module so that you can resolve those exercises related with Verilog programming. Then, we give here a reference, again, the Harris book, but you can find many tutorials or information in the internet for all these concepts. Then there's a video talking about the input-output specifically in the RVFPGA platform. Again, this video is in Spanish, but there's an AI automatically generated English video. So you can use the one you prefer. And the video describes the RVFPGA input-output system in detail, focusing specifically in the peripherals that we will use in this course. which are basic peripherals such as the LEDs, the switches, and the 7-segment displays, both from a programming-based input-output point of view and using interrupts. If you are interested in testing and checking and working with more advanced peripherals, there are many labs in the whole RVFPGA package that you can download from Imagination in the provided link that I showed you before. There are labs about timers, about serial buses, such as the accelerometer in the board, the temperature sensor in the board. These use SPI and I2C serial buses. So if you're interested in using those, you have many explanations and exercises in the whole package. Here we'll focus on the switches, LEDs, and 7-segment displays. Okay, so in this video, as I was saying, those peripherals and the RVFPGA I/O system is described in detail. So we recommend you to view the video before the next session. In the next session, anyway, I'll explain again these concepts, so you can hear it again and ask me whatever you haven't understood or whatever you want. This is a new source of projects, alternative projects that you have to download because we're going to work with them in Module 2. I have downloaded this here in my laptop. It includes, it's here, alternative projects, and it includes several projects, several platform I/O projects that will use in the module. Okay, so you will download that in the virtual machine if you're using the virtual machine, or natively if you're working natively, and then you're going to look at several projects included there in the alternative projects that you've just downloaded, and they are guided, they are programs using these peripherals that you will be using later in your exercises. So one is LED switches that, as the name says, it uses the LEDs and the switches on the board with a simple functionality. There's the assembly language program and the C language program. You should look at both in order to understand, after watching the video, how we are using those peripherals to communicate with them from our program. Then there's another project called 71 7-segment displays C-LAN, which uses the 7-segment displays. So again, you should understand the program in detail in order to be able to communicate with the displays on your own. And finally, there's a guided task that asks you to compare a programmed input-output program and an interrupt-driven input-output program, one that uses polling and one that uses interrupts. So you are provided with these two projects, one called like this here, and another one called the same, but with the word interrupts, using interrupts. The first one uses polling. And you're asked to understand how this is programmed, both with polling and with interrupts, and then to compare its behavior and to understand that interrupts behave better in some scenarios, such as the one shown in these programs. Okay, so this is the work that should be done before next module. So reviewing input, output, and Verilog concepts, watching this video, and testing all these programs in order to be prepared to complete the exercises that we'll ask you to do in the next session. Okay? This second module has two parts. This is the first part, and then the second part, which I think is maybe more interesting because this is the kind of exercises that you've probably done when studying your degree. Probably you had a board and you were asked to do some different things communicating with the peripherals. The great advantage that we have when using the FPGA and an open source and a SOC that provides all the sources for the SOC in Verilog is that we can see at a low level how everything is programmed and even change it. And that's what we'll do in the second part of this second module. On the second part, which is not released yet, but what we'll do is we'll understand how a hardware controller is programmed in Verilog, and then ask you to modify its functionality, to extend it, and be able to do some other things. So that will require you to first understand how the Verilog code has been developed for that hardware controller, then be able to modify it to extend the controller functionality. Okay, so that will be the second part, next session, third session. So we'll talk about that later. This is just an introduction of what the whole module will be about. The first part is what I've described for the next session. The second part, I'll describe it later, and we'll work on that on the third session. Okay. Any questions? Any comments?
Yes,
Here.
one question.
Yes, Jordi.
Regarding to the homework, let's say, do these need to be in the reports?
No. The previous work that you have to do before the session is just for preparing for being able to develop the exercises. What I want you to include in the reports is only the exercises that you do in the session. So, for example, for module 1, exercises 1, 2, and 3, and also optionally you can include exercise 4. For the second session, I've not released yet the work that you have to do, and this is only preparatory work for the second session, but you don't have to include it in the report.
Okay, thank you.
Yeah. More questions, more comments? Okay, so now you can go back to work, and we'll keep working till around 14. Okay, if anyone has to leave a bit earlier or whatever, no problem. And I'll be here till 14 to answer your questions.